All right, everyone, welcome to another GoLab session. We have a really special talk for you today by Miriah Peterson called Data Engineering in the Go Shop. Let's bring her live just to say hi and introduce you all to her.
Hi, guys.
It worked. Hi, Miriah. Happy to have you back here.
I'm excited to be here again.
Yeah. Yes, again. Awesome. All right. So for those of you who haven't gotten the pleasure of meeting Miriah, she graduated from BYU in 2017 with a bachelor's degree in physics. She attended one semester of graduate school at the University of Oklahoma in 2017, but dropped out to start a career as a software engineer, as many do. She currently is a data engineer at Weave in Lehi, Utah. She has given many talks on machine learning, data engineering, and data architecture strategy. Additionally, she works in the community as a board member for the Forge Foundation, Inc., and organizer of Go West Conference, Women Who Go Utah Meetup, and Machine Learning Utah. So about today's talk, it's all about how data engineers today work primarily in Python and Java to create large-scale pipelines and data platforms for their companies. As a data engineer, she has spent the past 2 years working exclusively in Go. We have had a variety of unique data problems, such as hippa and PII, I don't know, requiring PII, okay, over 40 plus third-party data sources, cloud scaling, and so on. They ended up building out data platforms mostly from scratch and learned many lessons the hard way. So in this talk, she wants to share what she has learned and tips and tricks for success. So thank you for that. And without further ado, let's watch the video. Thanks.
Welcome to my talk today. I am so glad to see you guys at this point in the conference. It is my first time at GoLab, my first time speaking as well, and I'm Miriah Peterson. I'll be talking about some tips and tricks for data engineering in Go. I am a data engineer at Weave. We are located in Lehi, Utah in the United States. I'm also a board member with a nonprofit called the Forge Foundation, which means I have the pleasure of doing meetups. We recently wrapped up our own virtual Go conference. I do have 2 dogs. They are unfortunately being babysat so that they do not bark or interrupt this talk. In the cute ways that they do, and I invite anyone to feel free to reach out to me at any point during or after this talk. I'd be happy to chat via the interwebs. Today, I will be telling you a story of some of the adventures that I have had building a data ingestion pipeline at Weave. Unfortunately, I do think you do need a little bit of context to understand why some of the choices were made. So to do that, I would like to introduce you to Utah. We are a relatively young, new tech scene. We have some companies that are quite large, but we do maintain a relatively sheltered and protected life. We think we are a lot bigger and more advanced than we are. We like to think that we rival some of the San Francisco-based companies, but the truth is we are not very diverse in our product. We provide a lot of solutions or services for the small business or for a company that has fewer than 1,000 employees. And because all of the companies provide similar products, we look for unique ways to kind of differentiate ourselves. At Weave, where I work, one of the major ways we differentiate ourselves is by doing Go. And not just a little bit of Go, but we are a 100% Go backend. We have Go in all of our apps, all of our services, everywhere. We're also very involved in meetups. We sponsor the local Go meetup, the local Women Who Go meetup, and we are very public in our little sheltered area. That being said, because we have a young, vibrant tech landscape, and because Weave is such a prominent player in the small Utah tech landscape, a lot of people approach me as a data engineer at Weave about really sometimes basic questions, such as this one here. Feel free to read it, but essentially what it says is, how on earth do you build pipelines in Go? Like, everything's in Python, everything's in Java, so do you not do it in Go? Are you just doing everything in SQL queries? Like, how are you monitoring it? How are you preserving state? How are you making sure that it has good quality? Like, how on earth are you doing this in a Go ecosystem? And so I very politely respond, as I do to all of these comments, that we do it very carefully. And sometimes naively, but very carefully. So as we go forward, I would like to just share some of the tips and tricks that I've learned over the past 2 years working at Weave and building data pipelines. We, at Weave, our major data pipelines are not for machine learning, business intelligence, or data science uses. They are for our product because we ingest a lot of third-party data that is provided to our customers. So I will have broken this talk into 4 sections. We have the platform section, we have the data extraction section, we have a section on loading data, and a section on data transformation. And these are all very important parts in building data pipelines and data engineerings, and a lot of places where I have stumbled and where we, as a team, have stumbled along the way. So when I say platform, I'm referring to the infrastructure used for data management, for storing the data, for transferring the data, ingesting it, for serving it up, for analyzing the data, and for transforming it into usable formats or usable types, usable formats. I was trying to look for another word, but format is the best word. And the platform is oftentimes the most important part because it is the backbone in providing good data, in providing high quality data, in providing to the needs of the consumer, whether that be an application. In most cases, it ends up being a machine learning engineer, data scientist, a business analyst, but ours does, like I said, it goes directly to the customer experience. So we put a lot of emphasis in data quality and data security. So my first tip, and this is a very important one, is if you don't have to build it yourself, just don't. There are a lot of people that put time and energy and effort into amazing open source solutions. And a lot of these solutions are in Go. You can use Pachyderm for data versioning in your machine learning pipelines or in your data analysis pipelines or BI pipelines. You can use Apache Beam as a streaming pipeline for transforming your data. You can use Google Dataflow, which is Apache Beam, just not open sourced. But that as well has the Go SDK and that you can use for managing your data or building your data pipeline. And really, just because of the support and the hours that have gone into it, it'll save you a lot of headaches to use one of these solutions. But inevitably, we all have different data needs. We all use different data, and so a lot of times we have to end up building our own solution. And the first tendency that I think most people have, and at least I have, is to assume that we know all of the problems and to just over-engineer the perfect solution that will work for everything. That's not the case. It's really hard to know what you need until you are knee-deep in your data, or chest-deep in your data, or until you are 3 years into the project and you're providing production data and you're going to have to reevaluate the situation because it's just not quite right. That being said, at the beginning, when you go to build your platform, you do need to be very aware of constraints on your data and your security requirements. Do you need your data to be encrypted over the wire? Do you need your data to be encrypted in its stored location? Do you have compliance issues on your data? Is your data protected by GDPR? Is your data personal identifier information? Is your data, in the United States, we have a lot of restrictions on persons' medical data. And unfortunately, we at Weave, a lot of our small businesses end up being medical offices or dentist offices. So we do have to be very aware of those kinds of security or compliance restrictions on the data and make sure that at every step of your process, the data follows those protections. And then another thing that I do recommend is that you build time in your project for iteration, for improvements, for making it better and easier to use, for making it more stable, or just for scrapping it and rebuilding it. Like I said, you're not going to know what your needs are, or you will know what the expectations are, but you're not going to know what the data looks like. You're not going to know what your system looks like until you're using it, until you're, like I said, knee-deep in the data itself. And you're going to need to be able to iterate according to the needs of the data, of what you're trying to build and maintain. And so, take that into account. So, that being said, as part of engineering it, one of the things that I personally found hard when we started was deciding on an architecture. At Weave, we are a microservice architecture. We have a ton of microservices deployed, but it's sometimes hard to build data pipelines in microservice land. It's a lot easier to do it in a monolith for a variety of reasons. But the first one being data integrity. You don't have to store the data in multiple places. It's stored in one place and accessed by one thing. And if changes are made to the schema where the data is stored, or if the data is changed to ingest, one change can be made to the entire monolith and you don't have to update many services. But if you're like us at Weave, and you choose to follow a microservice architecture, there are quite a few hiccups that you can run into. One is creating unnecessary services, creating a whole ton of things to maintain and to maintain deployment schedules on and to keep updated and versioned. There's a huge tendency to make each step in your pipeline a service, or each little transformation a service. And And you really need to try and limit those steps or limit those services so that the data isn't transformed unnecessarily, or so that the data state isn't accidentally migrated in a way that affects your customer. That being said, you need to be very aware of how many times you're caching your data, how many databases are copying your data. You don't want to have too many copies of your data, because that encourages the data to migrate or to not be consistent across all of the copies. And you do want the data to be as consistent as possible throughout the entire pipeline, especially for your customer. You're going to want to be very aware of how many times a data leaves one service and goes to a new service, how many times it is transferred, how many times it goes over the wire, because that can introduce vulnerabilities, that can introduce memory leaks, that can introduce latency to your data, or other kinds of shifts in a data state. And one of the things that I personally had an issue with is trying to take advantage of Go routines or Go channels and use it as a queuing system. They're always attractive, and everybody's going to echo this, that you need to be wary when you're using channels and Go routines in your architecture. I think for large-scale data pipelines, it's better to use a different queue or messaging service that kind of removes the data a little bit from the actual code or from the actual binary runtime, just for the protection, in case your service crashes, or in case if you have multiple replicas of a service and one of your replicas goes down, all of the data in that Go routine or in those channels will be lost, but the other ones won't be, and you start getting unstable data states. So in that case, I recommend using streaming services or messaging services to manage your data flow. I wouldn't recommend using APIs within your pipeline because they just slow things down. They introduce latency. They have all kinds of throughput networking errors. You could have rate limiting show up, and this is all internal. It doesn't make sense to have those kinds of things. It also doesn't allow you to be as dynamic as messaging services can be. For example, if you use NSQ and you get a huge bump in the messages in your queue, you can spin up extra workers or extra replicas to handle that bump, and then you can spin them down after the fact. I just realized I said NSQ without a lot of context. When I say streaming or messaging services, I'm talking about things like RabbitMQ, NSQ, NATS, Kafka, Google PubSub, Kinesis on AWS, and things of that nature. Another thing that messaging or streaming systems allow you to do is they allow you to do batches based on timestamps, based on loads. Batches then allow you to provide a liveliness metric for your consumer, for the customer, to say, hey, your data is going to be 5 minutes from live because we batch every 5 minutes, or 15 minutes, or 20 minutes, depending on your service. And just a note about Kafka. Kafka is a very powerful streaming and messaging service. It is not necessarily the most Go-friendly service. The packages and libraries for Kafka just are not as nice as some of the Kafka connectors available in Java that Confluent maintains. But the benefit of Kafka is it allows you to replay your streams. So for example, if you get to an unhealthy data state because one of your services crashed or you had a replica go down, you can rewind to a certain point in time and then replay that data stream and allow your jobs to reprocess, which can help to enable a clean data state, which I think is a huge benefit of allowing a streaming service such as Kafka to manage your data flow. Something that becomes very important when you are transporting data from one place to another internally becomes a schema repository, and this becomes infinitely more valuable when you're using the microservice architecture. It's very important to standardize your schema repository across all of your services so that they use the same repository. They're using the same data types. The structs are all the same. When something goes in to a messaging queue, it knows exactly what to expect when it's coming out. This allows for a lot of data integrity and a lot of data security. That being said, if it's possible, use your schema repository to generate endpoints, to generate code, to generate ingestion levers. This protects against stupidity. It protects against people breaking changes in one microservice that are not in other microservices, because it would have to be done in the schema repository. It would be generated all the way out, and it would protect your data state. We use protobuf, and we do generate a lot of messages for NSQ, for gRPC, for Kafka, using protobuf. We even use protobuf to manage JSON files, and to manage the repository across our JSON files, using versions that way, so that we know what to expect across all of our connections in data formats. Moving off of platform, something very important is extracting your data from its location. That could be from web scraping, that could be metrics data, that could be user data such as clicks, such as toggles, user activity. All kinds of great things have to be extracted. Like I said, our pipeline was focused mostly on third-party data, so we are extracting it from databases, from APIs, from really, really cool server setup databases from 1982 that we don't quite know what they were thinking when they set it up, but hey, if you have to go back in time 30, 40 years, you might as well go back to 1982 and use their data. But in languages like Python, you're able to leverage generics in this, so that you don't have to worry about type, you don't have to worry about types, you don't have to worry about formats. You just bring the data in, and you kind of can be very dynamic about it. Since Go is a strongly typed language, we can't leverage generic background or generic data types or generic ingestion. We have to be very specific. And that being the case, when you ingest your data, it's very important to try and not just use interface on everything and do it all over the place. You need to pick a data type, stick with that data type all the way through, and not try and transform it or manipulate it or cast it as many times as possible. Every time you change the data type, you're losing integrity. If you ingest a number that is represented as a string, and then you cast that to a float 64, and then you cast that to an int, you've lost a lot of the data integrity or specificity or accuracy that was originally there in the string, because you have cast it so many times. So I say pick one type, stick for it. And when you pick your type, think, what type is going to store the best in my database? What type is it going to need to live at long term? And if you're thinking ahead and you're being intelligent, you can go to your data source and try and leverage scraping or leverage metadata and try and understand what the data type is, so that you can define it beforehand. When we have gone into a database, we're able to do queries on the system tables to understand what the data types are and define those coming in, so we don't have to do casting and we don't have to be transforming the data types unnecessarily. If it's needed, leverage your scraping to get that information so that you can not lose a lot of your data integrity. If you have a complex data type, use your structs. Use go define types to help store that data as an object. And then use a pointer across your system. We start running into problems with memory or with CPU when we start copying the data and reallocating bytes every time we call a data point. This is fine when you have a couple megabytes, kilobytes of data, but when you start doing multiple workers and petabytes at a time, your memory gets sucked up really quick. And you can use pointers in Go to not reallocate those bytes and allow you to not stress your CPU in just really dumb, unnecessary ways. Another thing that can be really nice here is interfaces. You can define interfaces for a methodology or to keep a standard process on your data transformations, which allows you to have a complete picture of what your data needs to look like at the end of the pipeline. We do this with a lot of complex data structures that we ingest from our third parties. We'll have interfaces that define certain processes that have to take place on each complex type, and we're able to define unique types for each new source. And it really helps adding sources. It helps with creating data stability and painting a picture of what you want your data to look like at the end of your pipeline. And when you're doing extraction, it's not always the best case to do a fail-fast, close out the application approach. When you're dealing with huge batches and huge processes and you're working in parallel, a lot of the times, errors can stop a whole app mid-process, and can stop batches from processing completely, which can lead to unstable data state. It's good to manage your errors. You have to manage your errors, but try and keep them contained to an individual worker or routine or sub-process so that a worker itself may stop, but it doesn't stop all of the workers from working, so that you only have one data object or one data entity that didn't get pushed through your pipeline and not all of the data entities. Then try doing a back off or a retry approach to start that worker on that data entity again. And make sure that you track that you have a record of your data that's changed, so that you know this data object came in, it was not changed in our repo. We need to be aware of that. We need to know every time something was changed. We need to know every time a process doesn't go through, so that you can maintain an awareness of what your data state is and the data state that you are providing to your consumer. Loading your data is the next step. So when I say loading, I mean putting your data in its final long-term resting place. That could be a data warehouse, that could be a data lake, that could be a series of distributed databases, that could be a single server with a whole bunch of JSON files. You know what your needs are. But you need to be able to load it into a place. I recommend, if you're doing Go, leverage SQL. SQL provides a lot of dynamic processes that you cannot necessarily do in Go code. Find a good SQL library that integrates well, works well with your database, and you can use to do intelligent SQL queries. At GoLab, where I work, we use SQLX for a lot of our database queries for doing a manual SQL, and we do SQL C, which is a little bit closer to an ORM as well. That is newer to our code ecosystem, but is very heavily leveraged for keeping a constant data state. And SQL logic is very powerful and can really be beneficial for your data. It can help protect it. It can help provide just a base level security around making sure your data fits into its long-term data store, right? It can help provide sub-processes. It could help you with change data capture. It can help you do so many things just in the storage itself that's invaluable to your process. Like I said before, there are a lot of different kinds of data stores, and you're going to have different ones to fit your needs. Sometimes you need a database so that you can have it be highly available to a consumer. Sometimes you need a data lake so that it can have immense amounts of raw data that people can parse through, that they can search using S3 and Parquet, or that they can pull out and use for machine learning models. Sometimes you need a data warehouse so that you can run large-scale analytic queries, so that you can provide huge data insights based on sub-processes. Sometimes you need something else more specific. Sometimes you need more than one. Sometimes you may need a copy of your data in a database for that availability, for that quick access. And you need another copy of that in a data warehouse for your analytics processes. I'm sure all companies do this. But you need to find the one that fits your needs. We have a complex sharded database as well as a data warehouse for the analytics processes, and we have copies of data in all of them, in both of them. Not all of the data is duplicated in both of them, but we do have some data replicated in both for those needs. And we do make sure that our pipeline is serving up consistent data to both of those. And consistency is very important when you're loading your data into the data store. So in order to maintain consistency, you have to be very aware of when you do data migrations. You need to make sure that they are maintainable, that they are iterative, and that they have a good story for the person that's going to be consuming your data. I know it's really hard to think of a story when you're thinking of a migration, such as a database migration. But it really does paint a picture on what is there and what they can take out of the database, what they can consume. And it needs to be something that can be followed, something that can be read, and something that can be understood. If they get out of hand, if they start to be unclean, it will kill your data store. Like, you will not be able to come back and make a clean data state if your migrations are not clean. And it really just will make you want to pull your hair out or scrap your data store and start over. Another thing that's very, very important is watching your data change, or maintaining alerts and monitoring on what's happening in your system. This allows you to know if there's a problem in your data state and where it is, and it can make debugging your pipeline a lot easier. A little caveat of this, distributed data systems or distributed databases make this harder because it's really hard to manage transactions across replicas with your, because you might have multiple masters, you might have replicas, you might have different leaders, you might have people committing data to one database that has to be replicated to another, but then you have simultaneous transactions taking place. And if you're not monitoring your data change and you're not aware of what's happening, and if those conflict, it's just going to make your data a mess. So you really need to take care of that in the load step and make sure that you have a stable process for putting your data in its data store. So when we go into the transformation step, you need to be very careful about how you're storing your data. The data model is the story that you're telling the consumer. And from a large-scale data store, you're going to have more than one consumer. So you need to be very careful not to put a business data model or a very specific product data model into your storage. You need to be able to take your data and make sure that it stores well, whether that be across multiple tables, whether that be across multiple schemas. You need to make sure that your type is consistent and that it can be discovered by the person that wants to consume it. But it should not be limited by a product use case. That's something that we have been pigeonholed into at Weave, and it's really hard to reverse engineer that out. I do notice that my camera is freezing. If I do not re-record this, I apologize for that ahead of time. So, when you're transforming your data, don't be afraid of generating your code. You may need to be dynamic in the types that you have to transform. You may have multiple types coming in to be served up as the same data type, and generating code can be very helpful with this. Here's an example of a way to create a template for generating your code. You could have this be for slices of bytes, for strings, for int, uint8, if you need to, so that you can have the same function applied to the different types, and that when you're putting something, when you're serving it up for the user, or when you're putting it into the database, it all ends up in the same format long term. And you're able to really standardize your data as it is to be consumed. But again, when you're transforming, be very aware that you're not trying to pigeonhole feature logic or product logic into your transformation steps, whether that be into the database or whether that be at an ingestion point. That really makes it hard for you to expand your use case or to allow unique consumers. And it's like putting a square block in a round hole. It just doesn't belong in the data pipeline. You need to be able to provide a dynamic picture of all of the data available and let people pick out what they need for their use case. camera issues. Looks like I will be editing this. And while I'm here, I'll just take a drink. Live data updates or data insights are possible as part of your pipeline. This is a method of transforming your data because it takes your data and puts it into a new state on the end. They're very attractive. There's a lot of benefit to doing this, but they end up being kind of hand-wavy and magical. And a lot of times you can get these live insights from a separate batch process that's not built into your pipeline, but is run later on off of a data store. But if you do want to do a live insight as part of your data pipeline, you can do things like caching with Redis and jobs off of your Redis. You can use streaming pipelines such as Apache Beam that do have data analysis and machine learning functions built into the stream. You can also run online machine learning jobs as part of your step in your pipeline before the data is stored to provide dynamic insights as part of your machine learning model. But they are hard. I haven't done them because we get a lot of our benefits at Weave from just doing batch processing on insights. So we've covered a lot, and I would just like to summarize it real quick. So you need to build a smart data platform. You need to build a data platform that is stable and can serve up your data in a very dynamic way to all of the people that need to consume it. You need to be very aware of the data you're extracting, define it, and basically send it on its way in a stable, well-defined format that can be loaded into your database, put in the right place, so it doesn't need to be overly transformed and overly manipulated, and so that you can just be really methodical as you do all of the steps going forward. Make sure that the data is put in the right place for the right purpose. If that data needs to be highly available, you want that in a database. If the data needs to be used for analytics purposes or large-scale jobs, you might want that in a warehouse. And make sure to not over-transform your data or overly manipulate it. Be very strategic about it. Things that we've learned. There are a lot of pitfalls in data engineering. It's not easy, it's complex. There are a lot of tools out there, and you can use those tools to not have to do it yourself. I do recommend using all of the tools out there. The tools may work best with Python, they may work best with Java, they may work best with, I don't know any that use C, but there might be C. You might be writing Smalltalk if somebody did that. I think Go is the best language ever. I recommend using Go for everything, but you have to fit your use case and you have to best serve your customers. And like I said, that's all I've got for today. Feel free to contact me. And I just wanted to include some references for places to go if you have more information. These slides are available on my GitHub, so you can follow any of those links to get more information about different streaming services, different data types, methodologies, and all of those great things. Thank you again for this wonderful opportunity to speak to you. And enjoy the rest of your conference.
There we go. All right. Perfect. Hi, everyone. Welcome back. We are going to go live now with Miriah to answer your questions here. Hey, Miriah, let me bring you up. There you are. Hey.
I'm back.
Yes, with a working webcam. Yay. Fantastic. So I want to say, of course, again, even from yesterday, thanks so much for being here, even virtually. It's a pleasure to have you.
I'm super excited to be here.
Fantastic. Yes, yes, yes. Before we go to any questions that anyone has, do you have anything you wanted to add to your presentation?
Just another apology for those technical difficulties. I really wanted to fix them, but I was unable to find the equipment in time. So I hope everything went well. And I don't want to discourage anyone from trying to data engineer using Go. It's a great language for it. It just doesn't always have the tools that you find with other languages.
It's all good. Yeah, we definitely understand the difficulties. Great. Well, I see that you have read the question that we had in Q&A. Fantastic. I'm just going to read it out loud in case anyone who is watching the video later might be curious of questions other people had. And it was Tariq who had a question that said, this might be a dumb question. It's not. But I could not make sense of the code snippet you displayed. Could you put me on the correct track to understand it by mentioning some term to Google or some link to follow? And then you did put a link there for more detail.
Yeah, I'll be happy to repost that link in the chat in a minute. So the code snippet I showed is not 100%, I think, human readable, because it is a template for generation. Like, those still kind of confuse me because of a lot of the keywords and a lot of the kind of directionary terms that are put in there when the Go generate template library passes through it. And it's really good for things for basically regenerating functions or interfaces for multiple types. Like if you needed to have the same function act on a string and a slice of bytes and an array of numbers, you can go ahead and you can make a template similar to this. It would be just a text file that would have some Go-looking code with a whole lot of raw text in it, and you would then use the Go generate tool that's part of the Go binary to be able to parse out those keywords and put in different types instead of there. At the Go West conference that I run, a maintainer of Apache Beam was on there. He's been working on the Go SDK package for that. And since Go doesn't have generics, he has to do a lot of generation for every single type available in Go. So he goes into a lot more detail about generating types and how to use the Go tooling around that.
Got it. I heard generics again, and my mind went into a little bit of panic from yesterday. All right. Thank you for that. And yes, you put it in the chat, the YouTube link. Thank you. We've got another question here from Owen who says, you mentioned Go doesn't have the tools which a lot of other languages do. So what kind of tools do you use day to day that you wouldn't get in Go?
To be fair, I avoid Java like the plague.
Sure.
So day to day, I don't use any of the tools in Java. But a lot of very common tools are written in Java, and then we'll have Python plugins because Python is such a heavy data science and machine learning language. Very common tools that people use for this would be like Apache Airflow. That is a very common scheduling platform for large scale pipelines. Apache Spark, Apache Hadoop, Apache Flink. Those are all streaming services. Hadoop is actually a large scale storage service, but Spark and Flink are used for streaming pipelines as opposed to batch pipelines, which Go does not have. I looked at their streaming libraries and they're just not like really awesome. Unfortunately, nobody maintains them. So the difference between streaming and batched is you go and you process a set or a chunk of data at a time, and stream, they want it to be live. So you don't do chunks. You almost do every data point as it comes in. That's the goal. Go doesn't have that. Those are only Java and Python at this point in time. Kafka is also another huge one that we have used a lot in the past experimentally, but there's just not a whole lot of packages in Go that just like connect super well. And since I avoid Java like the plague, we scrapped it and we just do NSQ and try and work out some of the bugs.
Okay, thank you for that. Let's see, any other questions that I've missed? It looks like those are it. Oh, wait, okay, just go. Okay, fantastic. Well, if that was the last question, I just want to say, again, it's awesome to have you here. Hopefully next year you can come. We'll see if the situation gets any better. Next year, fingers crossed. Yes, exactly. Yeah, we'll save some good food for you. Was there anything else that you wanted to add before we say goodbye? Was there anything else in chat? Nope.
No, but feel free, if you guys have any questions that come out later, to reach out to me on Gopher Slack or on LinkedIn or on Twitter. I'm always available to answer questions at any point in time.
Fantastic. Yes. Andrea Favilli says greetings to your dogs too. Oh, fantastic. All right. Well, I want to, just from behalf of all of us at GoLab, thanks so much for coming. And hopefully you've enjoyed a little bit of the interaction as well.
It's been awesome. Thank you so much.
Yeah, thank you. All right. Enjoy the rest of your morning.
Bye, guys.
Bye. All right. Wonderful. So we have just one last talk of the day starting in about 18 minutes from now, called Clips Go, an expert system shell for Go, system shell. So we have that in 18 minutes. So I hope you all enjoyed this talk. If you want, you can go to the GoLab agenda page and rate it. Always giving feedback helps our speakers and us to create a better experience for all of you listening. So thank you, enjoy, and hopefully we'll see you with the next talk. Take care. Bye-bye.